Hey everyone. So today we'll try to solve this problem which goes by the name largest element in an array after merge operations, right? So we are given a zero indexed array nums and we can perform multiple operations on it, right? So the kind of operation is only one, but we can perform that operation n number of times, right? So n can be anything. Now the operation, right? So first if we try to understand the operation says that you pick any element I such that I is less than n minus 1. So here n is the length of that array, right? And then you see if the next element to that is greater than or equal to, right? If that is true, then you can add the ith element's value to that I plus 1. So for example, if we try to take example of the first case, which is 2 3 7 9 3. Now here 2, if I pick 2, right, 2 is less than or equal to 3, then 2 can be merged into this, so it will become 5 7 9 3. Now in the same way, 5 is less than 7, so it can be 12 9 3, right? Now this 12 is not less than 9, right? 12 is greater, so this cannot be merged, right? Now this is the operation that we can do. Now what question wants us to return is return the value of the largest element that you can possibly obtain. Now if we go by this route, then the largest element is 12, right? Now, but this is not the best. This is not the best value that we can get. Now we'll go by different route, right? 795. If I 793, right? So if we take 9 first and then see that the element to its left is smaller, you merge it, it becomes 16. Then you take 3, it is smaller, you merge it. Then you take 2, it is smaller, you merge it. It is 21, right? Now you see when we started from left, the largest value we got was 12, but now the largest value that we got is 21. So 21 is the answer for this test case, right? Same way, we'll consider 5, 3, 3. Now here the condition is only satisfied for these two elements, right? The next element is less than or equal to, then you can combine it, and then now the condition is satisfied for even these two, then it becomes 11. So 11 is the answer for this one, right? Now when we solve these two cases, right, there is one intuition that comes to our mind is that when we started from left, we couldn't reach there, right? We could only reach 12 because the the sum that we were doing from left, it kind of increased the value that is there, right? So for example, here it became 12, and this now 12 is kind of greater than 9, right? So now you can't merge it, right? But when we went from right side, then we could see that the chances of merging this element, right, was more, right? So that's the kind of hint that the problem is, right? But now I'll try to give you a kind of a better way to think this, right? So think of the operation in a monster kind of a way. Let's suppose that you have a monster which is placed at the last index, because this monster can eat its left, right, if it is less than or equal to that element. Now this monster, now our aim is to increase the maximum value that monster can eat. Now this 3, it has power of this 3 it has already eaten, right? That's the value of this monster. Now if we say that it can eat this 9, then its value will become 3 plus 9. But now the problem is that it can't eat, right, because that is greater than its value. Now when we see such this case, we have to consider a new monster. So this 9 is our new monster. Now then we see that this 9, which is our new monster, can it eat 7? Yes, it can eat 7, right? So we'll eat that. So now the value of this monster will become 16. See, now when we have added this to this, now the chances of this 16 eating the next element is more than just the 9, right? So for example, if there was a 15 here, right? If there was a 15 here, then if I could have said that no, I just want to start from here 17, right? And then 17 won't be able to eat 15. But now the combined power of these two, right, it can eat 15 also. So that way you will get the largest element as 31. So that is the intuition behind this problem, that you start from right side, because the rightmost element can eat the leftmost element, right? That's the merge operation that we can do. So you start from right, and then you see if you can eat the current element, right? If you can eat it, well and good. You add your the value of that element that you have just eaten to your current value, and then you move forward, right? Move to the left side. But if you can't eat, then you have a new monster. So for example, let's take this example as well. 2, 3, 7, 9, and 5. Now here, this, after eating this, you will get a value of 21, right? Now this 21, can it eat this monster? No, it can't eat, right? Because its value is still less than. But so you have a new monster which is goes by name 22 now. So this becomes your answer, right? Because you tried from the best case possible, still you can't eat the 22nd, so that the monster that is with the highest power, that is 22 here, right? So that is pretty much the approach. It is kind of a greedy approach that we follow here. Now to code this solution, right? I hope once you have understood, you will be able to solve it, but still, uh, we'll try to code it together. So this is the length of our array. Now, as they say, right, as this problem state that it can be of answer, it can be in long, right? So we'll create that answer is nums is equal to n minus 1. So this is for the case when there is only one monster, right? For example, when there is only one, that is 10. You have only given one monster. What is the largest value you can return? The value of that monster, right? Now, but at every index, you can also see that whether you can increase the value of that monster or you can start a new monster, right? So for that, you'll have a monster. Let's call it monster. And then that will be our last element for the starting. Now we'll loop from right to left till there is no element left in the array, right? We'll check our this current element, whether that is less than equal to the monster, right? Yes, it is less, right? Now this can be eaten by my monster, right? So I'll say that, hey monster, eat this value, right? So he has eaten it. Now the value of that monster has increased. Now we can eat more elements. But if that's the case, then I say that, oh monster, you are of no use. I'll take this as my monster, because the chances of this element eating the next element, that is we'll see on the left side, is more, right? Because this is a bigger element. Now once we do that, at every step we'll also see that whether the maximum, the monster value, right, or the largest value of that array is becoming greater than our current answer, right? So to do that, it's pretty much simple. Now if you want to understand it better, you can also do this here, right? At every step you do, but it is the same thing, right? But sometimes to understand it is better, like if at every step, whether it goes under this if or under this else, right? We have to check whether the largest value is increase or decrease. Once we do that, we just return this, and this is long, right? And then our answer is also long. So we'll try to run this and see if it works. Yep, it works for both the cases, right? We'll try to submit it. So yeah, the intuition, right, behind this question is just that you start from right and you keep on eating. The monster keeps on eating if he can. If he can't, then there is a bigger monster than that, right? So then you make that your monster. And then if you talk about time complexity of this is O of n, only because we are traversing only once. And that's pretty much it for this video, guys. Keep coding and all the best. Have a nice day. Bye.